referred to as the Einstein of our generation. Please, can we have a huge round of applause on that?
Yes.
Einstein of our generation. Despite his young age, his contributions to the field of science are truly extraordinary. His journey is a testament to the incredible power of curiosity, perseverance, and the pursuit of knowledge.
Before we dive into today's proceedings, let us take a moment to appreciate the impact of Professor Bari, who has made not only in advancing scientific thought, but also in inspiring young minds across the globe to dream big and aim high. At just 11 years old, Professor Isaac Bari has been recognized as the world's youngest professor, a prodigy who has captured the attention of the global academic community with his remarkable intellect and passion for science.
As said by Malala Yousafzai, let us pick up our books and our pens. They are one of the most powerful weapons. Professor Bari's journey into the world of academia began at an incredibly young age when he started solving complex mathematical and scientific problems that left even seasoned scholars in awe. His profound understanding of subjects like physics, chemistry, and mathematics has earned him recognition and accolades from prestigious institutions worldwide.
But Professor Isaac Bari is not just a scientific genius. He is also a strong advocate for education and innovation. He believes in the power of curiosity and is deeply committed to inspiring young students to pursue their interest in STEM fields. His mission is to make science accessible and enjoyable for everyone, regardless of their age and background. But before we proceed, let us take a moment to acknowledge the presence of our distinguished guests and dignitaries. Your presence here today adds immense value to this occasion.
And now, may I kindly request our Honorable Chancellor Sir, Vice Chancellor Sir, an Honorable Pro-Vice Chancellor Sir and Advisor Sir to present Professor Isaac Bari with a token of love and appreciation from the USTM family and a goodie bag comprising of organic products from the entire Northeast. Come on guys, louder. We need some claps. We need some claps.
We are also privileged to have with us the proud father of Professor Suborna Isaac Bari, Mr. Rashidul Bari, teacher of Brooklyn Tech, USA, New York, and Mr. Pranesh Devnath, State Representative of Northeast India, Vyomika Space Academy, and India Coordinator for Professor Suborna Isaac Bari. And now I would like to request the proud father of Isaac Bari, Mr. Rashidul Bari, to come over the dais for the felicitation. And now I would like to request Mr. Pranesh Devnath to come over the dais for the felicitation program.
Mr. Devnath.
Mr. Devnath, can you please come over the dais?
Mr. Devnath.
Mr. Devnath, we request you to come over the dais for the felicitation.
Mr. Devnath, can we have a huge round of applause for Mr. Devnath?
India, Vyomika Science Space Academy, and India Coordinator for Professor Suborna Isaac Bari. Can we please have a huge round of applause again? Now start.
Thank you, sir. And now the moment we all have been eagerly waiting. But before we begin, I kindly request the dignitaries on the dais to proceed down and enjoy the wonderful session from the audience. Today, we are truly honored to have Professor Isaac Bari with us to share his insights and experiences.
Professor Bari, we are all eager to hear your thoughts. The stage is all yours now. Can we please have a huge round of applause?
Guys, louder!
So can we hear it for Professor Suborna Bari once again? A big round of applause. Professor Suborna Bari, the stage is all yours.
At the end, national anthem, okay?
At the end of the
No, at the end of the speech, national anthem. Huh?
no, at the end of
Introduction? Okay.
Thank you very much, ma'am. It's my honor to be here today. Greetings, namaste, and assalamu alaikum to the entirety of the University of Science and Technology, Meghalaya. It is my honor to be here today. Now, today, I want to keep this lecture short, as always, because you may have seen the itinerary. This is supposed to be a 1 hour or so long lecture, but what I really want to do is keep it short, because the best speeches are the ones that keep your viewers' attention for the duration of the speech. And of course, I can't do that if it's 1 hour. Half of you are going to take out your phones by then and just scroll on some random social media app. So, why am I here today, and why did I specifically choose to talk about the impact of early STEM education? Well, it should be pretty apparent that I was given some early STEM education myself. And I think that early STEM education, I've said it 3 times by now, but the impact of educating your kids at a young age about STEM might be one of the biggest things that has ever been seen. But people don't really use it that much, use that opportunity. The thing is, everybody gets exposed to STEM technically at a young age. At 3 or 4 years old, you start counting, you start adding, you start subtracting, but you have so much potential to help your kids understand before then. Now, of course, I'm not talking about making your kid do calculus. I'm sorry? Oh, okay. I'm not talking about your kid doing calculus at the age of 2, but I think that early exposure, now the people in the back can't hear me. So early exposure to science, technology, math, and engineering is one of the most important things any child can have. And why is that? As we become older and older and older, suddenly more and more people start getting this fixed mindset. They believe that either they are right about everything, or when they don't know, their teacher is right about everything. One time, yesterday, in fact, I was giving a public lecture quite like this one, and right after, a question and answer session at the ERD Foundation Guwahati. And we were having some high school students come on and ask me a few questions. So, one of them asked me a very profound question about set theory. If you have a set of every single set, does it contain itself? Is it even a set? And I think, personally, the answer is no. Why? Because something that contains multiple sets is not a set itself. That would create multiple paradoxes. It is what we call a collection of sets, and a collection of open sets, a collection of closed sets, whatever you want to call it. It's a collection of sets, not a set containing other sets. All a set can contain are numbers. Of course, that's in the sense of real and complex analysis, not anything else. But this student refused to think any differently. This student haggled with me for half an hour. While all the other students, I answered their question for 5 minutes, and then they went away. This student told me, "But I don't believe you, sir. Why do we even need the concept of a collection? Cannot a set be an element of another set?" And sometimes it's good to be hard to convince. It shows that you're not just taking what anybody says for granted. You actually want to see what's in there for yourself. But then I explained to him, if you have a set that contains other sets, what if that set contains itself? Wouldn't that create multiple paradoxes? What would be the length of the set? What would be a subset of that set? So things would be very complicated if we did not simply call this object something other than a set, something that we call a collection of sets. But he refused to believe me. And at one point, he even cited a definition that a set is a generalized collection. And I asked him, well, I just used the word collection, but a collection of what? What is a set? What is it a collection of? And I mean, most of you would fill in the blank as numbers, whether it's natural numbers or rational numbers or real numbers or complex numbers. But he didn't answer my question. He just said it's a generalized collection. A collection of what? Shapes, fruits, words? It doesn't really tell you anything. So, what I told him was, I mean, this isn't how a set works. A set can only contain these amounts of numbers and nothing more. If we have multiple sets, then if we have an object that contains multiple sets, we call that a collection. And so he said, okay, thank you so much, sir. But the look in his eyes told me he wasn't satisfied at all. So, I mean, these people have fixed mindsets. Why? Not because they are actually listening to anything you say, not because they just want, not because they actually want to find the truth out behind anything, but because they can't be convinced that they're wrong. They can't be convinced to think from a different perspective. And of course, if any of you are in political science, for example, or law, you will have probably seen this all the time. But in terms of math and science, this is a very pertinent issue as well. And this is why so many people drop out of math and science majors as they go on. When it comes to your high school, all you have to do is pass tests and get good grades. When it comes to your bachelor's degree, your BSc, you need slightly more creativity. You need to understand how to conduct experiments. You need to conduct some research for yourself if you want to get into a good graduate school, etc. It takes a little bit more effort. But when it comes to your PhD in any STEM field, the difference of that is in your bachelor's degree in your high school, you're learning stuff that other people have already created. But when you talk about a PhD, you're asking someone to create knowledge that has never been found before. And oh boy, is that incredibly hard if you have a fixed mindset. If you can't think about anything, if you can't stand to think of something from a different point of view or connect two things, then, I mean, you're never going to get anywhere. You're never going to get your PhD. And that's why almost half of people, at least in the US, the data is, about half of people drop out between their high school and their bachelor's degree when it comes to math and science. And only about 30 or 40% of people who complete a bachelor's degree in math, in physics, math and science, of course, only go on to get their PhD, which is a very unfortunate thing. Why? Because, I mean, so many people say these courses, differential calculus, integral calculus, multivariable calculus, they weed out the people who aren't worthy. But who isn't worthy of math? Who deserves to be weeded out? Who doesn't deserve to actually be part of the future of how our world works? I mean, nobody. Nobody should be excluded from math and science. So why do we say these classes weed out so many people? And when we say that, why are we correct? Why do so many people drop out of STEM once they get through the ring of calculus classes? Or even earlier, most people can't drop out of STEM when they're in middle school or high school, but they completely lose interest when it comes to variables and such. Many people I hear, at least in the US, say math got much worse when letters started coming in. And it's so confusing to them. So why do these classes weed out so many people? Well, here's my understanding of it. Math and science has become so robotic over the ages. Not math and science itself, in terms of the front line of discovery, but math and science education and Common Core. Not just in the US, but everywhere. Math and science has become the same formulaic approach repeated over and over with different problems when it comes to school. And of course, a lot of problems, textbook problems in India have a bit more steps than those in the US, but still, they're nowhere close to anything you would actually find in the real world, which not only requires lots of formulas and creativity, not just a lot of formulas, but also a lot of understanding and a lot of creative thinking, which is not what we see nowadays. And that's a very unfortunate thing. Of course, I hear that on the IIT JEE and on the JEE Advanced and the NEET, you don't really get that many formula seats. I believe you don't even get a formula seat at all for the JEE Advanced. So, in fact, I was asked a question from somebody's NEET textbook for one of the schools I went to, and it was just a formula question. It was just memorization. It was asking, what is the induced magnetic field around the current carrying wire? And obviously, everyone who's a physics major knows the answer to that, mu naught I over 2 pi r. But it's just a memorization question. There's no actual substance to it. There's no actual understanding. And I doubt that anyone who's teaching this actually bothers to explain why this is in class. They just say, here's the formula, move on. And the worst thing is, in the US, you get these formula sheets. So they have to come up with more creative questions than, what is the formula for this? But in these questions, no. All you're asked to do is memorize. There's no real creative thinking behind them. And the most creative problem I received that day, when they were asking me questions from the physics section of the NEET, was a problem that used not one formula, but two, the continuity principle and Bernoulli's law. Two formulas. And they were just applied one after the other. No algebraic manipulation, no little twists or turns, absolutely nothing. And that's very, very unfortunate for us. We should be learning how to creatively think, how to actually arrange these mathematical and scientific formulas. But instead, we're learning what the scientific and mathematical formulas are, and not how to use them, how to understand them, or even where they come from. That is the most unfortunate thing about STEM education right now. But how do we change it? It's not like we can reteach every single teacher or replace every single teacher. That would be even worse. We simply don't have the infrastructure or the practicality for that. What we need is not to completely overhaul teaching over time. I'm sure that will work. But we need to find other resources on our own. So I think one of the most impactful things parents can do for their children to stop this kind of phenomenon happening, to stop them from dropping out of school, STEM as they become older because it's getting too abstract for them. The most parents can do and schools can do is teach STEM early. And of course, every school teaches science or math in some way once you're 3 or older. But what I mean is not teaching via the standard curriculum. What I mean is introducing these abstract concepts in a way that actually feels down to earth with them. I once asked one of my classmates who was failing in algebra, why don't you understand algebra? And this was at the beginning of the high school year, by the way. And he said, well, I just don't understand. In one equation, x is 2, and in the other, x is 3. How did it change values between those two? And don't laugh at him because, I mean, it's only natural for him to ask. I thought these variables were specific names for numbers. Now suddenly they're changing in between. I thought that x always meant 2. Why does it mean 3 now? And so many people are confused about this as well as other concepts in algebra and trigonometry in basic high school math. They don't understand that x isn't a name for specifically one number. They don't understand that x is just a mystery name. It's a general name we apply to a number that we don't know. That's why we don't just use the number in the first place. So these people don't understand how abstract math is. And how do we fix that? Not by introducing a whole new math curriculum that teachers don't have plans prepared for, but rather by introducing these concepts earlier, not to spend extra time on these small concepts, time that you don't have because you have to prepare for a bunch of exams that come at the end of the year. Instead, we have to spend time introducing these abstract concepts earlier. And of course, you may know, if you study the history of math and science, that people have tried this, at least as far as I know, it was tried in the US in the 1960s before, a curriculum that they called New Math, where they taught more abstract concepts on a simpler level. They taught set theory and group theory to 3rd and 4th graders. But the problem was, not only did they prioritize this new abstract math over things that students were supposed to be learning, like addition, multiplication, fractions, percentages, and so on and so forth? Not only did they prioritize the abstract math over the practical math, but even worse, most parents and even some teachers didn't understand the material that they were supposed to be teaching, which leaves me scratching my head because these people are supposed to have a bachelor's degree in math. But what I'm thinking is, why don't we don't have the infrastructure to make a change so quickly? And that's what you're probably thinking as well. And after only 5 years, a book was published named Why Johnny Can't Add, The Failure of New Math, and that quickly enlightened the public to what was going on, and the program was shut down. So I think this time something in that vein can work. But we don't need to make that switch immediately. That'll just harm people in the same way that new math did 60 years ago. Instead, what we have to do is we have to actually prepare not only our teachers, but the parents around us to help their children and their students with mathematics. We have to actually prepare these lesson plans a few years in advance. And most of all, if your teachers aren't changing, the only thing you can do is ask the one other resource you have at home, your parents. So your parents are the ones who are looking out for you. They're supposed to provide for you. And that doesn't just come for food and shelter and bills and stuff. That also comes for your education, your understanding. They're supposed to provide to you the things that you can't understand yourself. And so, for those who are parents in this room, I would like to ask you, please, learn at least a little bit of math, like my dad did. He was going for a degree in law, and he eventually thought he would end up going into law. But then, once he had his first child, my older brother, and then especially once he had his second child, me, he thought, I need to help these kids with math and science. I need to inspire them in some way that will leave a mark on them. And so he decided to get a math degree. And even though he failed 5 times on end, he failed Calculus 1 5 times in a row, he managed to get through it and get his bachelor's degree in math, along with 4 other bachelor's degrees. So I think we need a round of applause for the man who's currently hiding behind the whiteboard. But, of course, we're not done. Okay, you could go back behind the whiteboard now. Okay, so I'm not done. I think that the parents in this room today have to follow the example of my dad. They have to actually go out there and not do something as extreme as re-earn a BSc in math. I think there are actually age restrictions on that kind of thing in India. But at least learn a little bit of math. Help out your children. And don't just repeat textbook definitions to them. They already get that bullcrap in class, and they still don't understand it. You're supposed to actually intuitively explain it to them on a deeper level. And of course, they're children, 13 or 14 or 15 years old. They won't understand everything perfectly well. But I hope, hopefully you who is 35 or 40 or 45 or 50 or somebody is somewhere in that range. Why are the lights going out? You should be able to understand these concepts on an intuitive level and explain it to these children who are in need of help. So that's just my advice to all of the parents out there. And to the students here, not only the students who are still in middle and high school, junior high school and high school, but also the students who are currently in college. I'm sure there are some things you don't understand, not just for the people who are in math and science, or STEM in general, but also people who are in other fields, like commerce, economics, law, pharmacy, and other medical subjects, biology, chemistry. Chemistry is STEM. Anything else in that field. I think that people need to understand that they're not alone, and that textbook jargon and teachers who ramble on for the entirety of the semester are not the only resources that you're stuck to. So I think that although there are resources you could cling to when you're older, the biggest thing that can help you is the impact of STEM education early on. Giving your kids that education is enough to inspire them. So there are so many examples of this. But I think that just this early exposure, if they get inspired from it, they'll be able to do math for the rest of their lives. But as they grow older, this view is slowly cemented into them that math is just this formulaic slop, that it's not anything actually practical for your life. And that is the exact kind of mindset that you can avoid by teaching your kids early. So I would like to encourage you all, please, if you're planning to have a kid, which I'm sure is very few of you, or if you already have a kid who's very young, like 9 or 8 or 9 or 10, you have to teach them math now, because as they grow older, they will learn to stop asking questions. They will learn to stop being inquisitive. They will learn to not like math and physics anymore, or STEM in general, because that field is all about asking questions and being inquisitive. And they will simply learn that all they have to do is memorize the formulas and listen to their teacher and get good grades on their exams. So I implore you to do this now before it's too late. Thank you. No, Dad, you still have to record.
Water, glass of water. Thank you.
Water? I'm too strong for water. I don't need water. Oh, for you?